19 review. Number 1. A survey organization is planning to do an opinion survey of 2,500 people of voting age in the U.S. True or false? The organization will choose people to interview by taking a simple random sample. Wait a minute. So, survey organization is planning to do an opinion survey of 2,500 people of voting age in the U.S. True or false? The organization will choose people to interview by taking a simple random sample. I don't know what they're going to do. I mean, they should, but I don't know what they're going to do. Yeah, so if we change the will to should, then it would be true. Yeah, that doesn't make any sense. 2. 2 surveys are conducted to measure the effect of an advertising campaign for a certain brand of detergent. In the first survey, interviewers ask housewives whether they use the brand of detergent. In the second, the interviewers asked to see what detergent is being used. Would you expect the 2 surveys to reach similar conclusions? So, so they come into your house and they say, "Do you use Tide?" Yes or no? Or they come in and they say, "What brand of um, what brand of detergent do you use?" Right. So if you're like us, we buy whatever's cheap, right? Do we use Tide? Yeah, if it's on sale. So I might use it sometimes during the year, but it might not be if I were to pick one, it might not be the first brand I choose. So it's they're asking 2 different questions. Do you use this one? Means is it on the list of detergent you use? Versus the other question kind of assumes which one do you use most? So you're answering 2 different types of questions. Um, there was a really interesting study done by a man who claimed that hypnosis could take you back to any point in your life. And um, so he hypnotized all of these adults and he asked them what day of the week their birthday was on when they turned 4. And he had a huge success rate, like 70 or 80% correct. And he said, "See, hypnosis works. I can take people back." And over and over, people have tried to duplicate that study. And when they do it, the people are only right about 1 in 7 tries, which is what you would expect. So where did he mess up? Well, his survey was not double blind. Okay? He asked the questions, and he didn't say, now we're going back to your fourth birthday party. You see the cake. You remember the party. What day of the week is it? That's not what he said. He said, is it Monday? Is it Tuesday? Is it Wednesday? Is it Thursday? And something in his voice must have prompted them. Is it Friday? Yes, you're right. And and I don't think he did it on purpose, but he knew the answer when he asked the question, and he asked day by day. So without meaning to, he was biasing the results just by how he asked the question. Okay, which one are we on? 3. One study on slavery estimated that a slave had only a 2% chance of being sold into the interstate trade each year. Oh, how wonderful. This estimate turns out to be based on auction records in Anne Ardell County, Maryland. Is it trustworthy? Not for the population of all slaves as a whole, but in that one county, in that one slave auction in Maryland, it would probably be pretty accurate. 4. In one study, it was necessary to draw a representative sample of Japanese American residents in San Francisco. The procedure was as follows. After consultation with representative figures in the Japanese community, the four most representative blocks in the Japanese area of the city were chosen. All persons resident in those four blocks were taken for the sample. However, a comparison with census data showed that the sample did not include a high enough proportion of Japanese with college degrees. How can this be explained? So they picked they picked the four most representative blocks in the Japanese area. Okay? Well, maybe the Japanese who have graduated from college don't live in those blocks. They must live somewhere else, which means that those blocks really weren't representative. Well, how did they know they were representative? You can't. You can't guess that these are representative without knowing. So obviously they were not representative. Okay, 5. Hypothetical. A survey is carried out by the finance department to determine the distribution of household size in a certain city. They draw a simple random sample of 1,000 households, so we're assuming they did it correctly. After several visits, the interviewers find people at home in only 653 of the sample households. Rather than face such a high non-response rate, the department draws a second batch of households and use the first 347 completed interviews in the second batch to bring the sample up to 1,000. I'm going to stop. Good idea, bad idea? Bad idea. In fact, you're making a bad idea even worse. Right? If you only contact those that are at home, you're going to have sampling bias. Is the estimate likely to be too high or too low? What are we looking for? To determine the distribution of household size in a certain city. So household size. Would people with big families be more likely to be at home than people with small families? I would say yes. I mean, if a family has a lot of kids, would you expect a parent to be home? Yes, more than a person that has very few kids. That's true. Yeah, you'd have more stay-at-home moms or stay-at-home dads. Yeah, but and and all they're looking for is how big the household is. So if one person's home, they can answer the question. So yeah, that's what I think. We don't have answers to these, do we? Ecstasy was a popular drug in the 1990s. It produced a sense of euphoria, um, derisively called the yuppie high. One investigator made a careful sample survey to estimate the prevalence of drug use at Stanford University. Two assistants were stationed on the main campus plaza and instructed to interview all students who passed through at specific times. As it turned out, 39% of 369 students interviewed said they had used ecstasy at least once. Does the investigator's procedure give a probability sample of Stanford students? Yes or no? No. People walking across the quad are probably quite different than people in general. Okay, 7. A coin is tossed 1,000 times. There are two options. To win $1 if the number of heads is between 490 and 510. To win $1 if the percentage of heads is between 48% and 52%. 2. That's true. But why 2? It's a it's a broader window. So it would be 480 to 520. Okay. 8. Can you tell whether the figure below is a probability histogram or a histogram for data? If so, which is it and why? It's probably a histogram for data because it's kind of bouncy. It's not. Probability histograms usually are quite smooth, and this one is not smooth. Now, you can't tell for sure, right? I mean, you could build a box that yielded that. right? You would just put, you start with 100 ones and 122s and 80 threes and 75 fours, and then you get out further and you don't put in any 10s and don't put in any 11s, but put in 5 12s and 1 16. You could build a box that would represent that, but usually probability histograms are much smoother. 9. One hospital has 218 live births during the month of January. Another has 536. Which is likelier to have 55% or more male births, if the percentage is usually 52? So, so we have 52% of all births are male, which is weird, right? But actually, there are more females on Earth than men. Men die for weird reasons. Yeah, right? Right? Your dad is more likely to throw a male baby in the air as high as he can. Right? Hey, watch this. Hang him, dangle him over the edge of the Grand Canyon, that sort of thing. All right. So, um, if we agree that 52% of all births are male, and that's a parameter, are we sure? No, we don't know. Right? We can't, that's not something we can find out. Maybe in the United States we can get pretty close, but in the world, we don't know. A lot of people never have their name written on a piece of paper ever. Okay. Yeah. So, one hospital has 218 births, and the other one has 536. Where would we be more likely to find 55% male? In the smaller one, how come? Because as n increases, the chance error goes up and the percent error goes down. So which one is likely to be further away from 52%? The 536 is probably going to be further away from 52%. But percentage-wise, which one will be further away from 52%? This one. So this one will have a low chance error and a high percent error. And this one will have a high chance error but a low percent error. Why is that? Why does the percent error go down? It's something to do with one of the equations. The square root in the standard error equation. That's what does it. So the expected value is the average times the draws, and the standard error is the SD of the box times the square root of the draws, which means even though the chance error is getting larger, it's getting larger slower than the population is increasing, than the sample is increasing. So that's why the percent error goes down. Okay, 10. A coin will be tossed 100 times. You get to pick 11 numbers. If the number of heads turns out to equal one of your 11 numbers, you win $1. Which 11 numbers should you pick? So we're going to flip a coin 100 times, and you get to guess 11 possible outcomes for the number of heads. And if one of your guesses actually happens, you win. 50. So you do 51 to 55 and 45 to 50. So everything from 45 to 55. Okay. What's your probability of winning? So one copy of 1 and one copy of 0. So the average of the box is 0.5, and the SD of the box, it's also 0.5. Because on average, how far away are those numbers from 0.5? 0.5. So the EV is going to be 0.5 times 100, which is 50. And the SE is going to be 0.5 times the square root of 100. So that's 10. Or sorry, 5. 10 times 0.5 is 5. So, do we need edges? Yes. So we want to go from 44.5 up to 55.5 with our expected value of 50. And really, we just need one of them. And then the easy way to do this would be using the table. Those are evenly spaced, right? So this is 5.5 divided by 5. So 5.5 divided by 5. Oh, that's not what I wanted to do. So 5.5 divided by 5, and I get 1.1. Why do I not need to do the other one? Negative 1.1, and we could do shade norm, but the easier way would be look at the chart and go to 1.1 because it's a middle area, and 1.1 would be 72.9%. A sorcerer has hidden a Porsche in one of an infinite row of boxes. Oh, great. The sorcerer will let you drive away from the car if you can find it, but you're only allowed to look in 11 boxes. He agrees to give you a hint by tossing a coin 100 times and counting the number of heads. He will not tell you this number or the number of the box in which he hid the car, but he will tell you the sum of the two numbers. Wow. Let me try again. So, sorcerer. A sorcerer has hidden a Porsche in one of an infinite row of boxes. The sorcerer will let you drive away with the car if you can find it, but you're only allowed to look in 11 boxes. He agrees to give you a hint by tossing a coin 100 times and counting the number of heads. He will not tell you this number or the number of the box in which he hid the car, but he will tell you the sum of the two numbers. Okay, got it. So we have the integers. Okay. And he's going to do two things. He's going to hide the car in a box. Okay. And he's going to flip a coin 100 times and count the number of heads. And he's going to add those two together. Okay. So the car is in box X, and the number of heads we'll call Y. He's not going to tell you what X is, and he's not going to tell you what Y is, but he will tell you what those values are when you add them together. Will we be able to find the car? Well, 73% of the time we will. How come? Because that was the answer to the previous question, right? We got 72.9%. So let's say he says the answer is negative 258. Well, what do we expect this to be? 50. So x plus 50 equals negative 258. So we're going to subtract 50, and we say that x is negative 208. Now, give or take, we get 11 choices, right? So we're going to go up 5, and we're going to go down 5. So we're going to guess from negative 203 all the way up to negative, oh wait, I got that backwards. These are negative numbers. Negative 213 all the way up to negative 203. We have a 72.9% chance of the car being in those boxes. because that's the answer to the previous problem. Wow, that was confusing. Oh, A. If the sum is 65, which 11 boxes would you look in? So we do 65 minus 50 is 15. So we would look in boxes 10 to 20. Okay? As in A, replace 65 by 95. So it'd be 45, so we'd look from 40 to 50. What is the general rule? Take the sum, subtract 50, and add 5 and subtract 5. D, following this rule, how likely are you to get the Porsche? 72.9%. That was the answer to number 10. 95 minus 50 plus or minus 5, so 40 to 50. Okay. 12. The San Francisco Chronicle. Right. So the sum minus 50, and then that answer plus or minus 5. Number 12. The San Francisco Chronicle reported on a survey of top high school students in the U.S. Cheating is pervasive. Nearly 80% admitted some dishonesty, such as copying someone's homework or cheating on an exam. The survey was sent last spring to 5,000 of nearly 700,000 high achievers included in the 1993 edition of Who's Who Among American High School Students. The result was based on 1,957 completed surveys that were returned. Their surveys do not pretend to be representative of all teenagers, said Who's Who spokesman Andrew Weinstein. Some are listed in Who's Who if they are nominated by their teachers or guidance counselors. 98% of them go on to college. Why isn't this the survey representative of all teenagers? They were chosen to be in that list. Okay. B, is the survey representative of the nearly 700,000 high achievers included in the 1993 edition? They sent out 5,000 surveys, and they only got 2,000 back. Would we suspect selection bias? Probably. Only 2/5 of them answered. 40%. That's probably not going to be representative.